Live from the Washington, D.C. area, it's the Emerald Planet. All the ecology news that our viewers want to know. Now, here's your host, Executive Director of the Emerald Planet, Dr. Sam Lee Hancock.
Hello, welcome to the Emerald Planet as we come to you on a week-to-week basis from Washington, D.C. in the United States as we look around the globe in 144 different nations looking for those 1,000 best practices, technologies, services, and products that make a difference as we move through the 21st century. And with all the natural calamities and disasters going on around the globe, we're talking in a three-series basis about various technologies that can be actually installed before you have a disaster. People are getting used to it. They're using it for economic development, community development activities. And at the same time, if you have a disaster, hopefully through distributed energy, water, sanitation, and other basic amenities, things will keep working as normal, even after the disaster strikes. But we have someone, we're going to be talking about water and how to bring water into communities. He's coming in by Skype. This is Alexander. He goes by Alex. Deichl, she is the Director of Marketing and Operations for WORLDWATER and Solar Technologies. And Dr. Linton Wells, who is sitting right beside me, he's a regular visitor with us, actually becoming more of a regular visitor with us. And he's the Executive Advisor at the Cyber Center, C4I, over at the Volgenau School of Engineering at George Mason University. And thank you for being here.
A pleasure.
Glad to have you. Alex, are you with us?
Yes, I am.
Alex coming in by telephone. Alex, thank you for being here, and thank you for sharing about these incredible technologies that you have, and we'll show some images of that as we're chatting. But tell us a little bit about the vision and mission of WORLDWATER and Solar Technologies.
Sure. Pretty much our mission at WORLDWATER is basically to make clean water and power available everywhere in the world through our proprietary solar technology.
Well, doing that, it's amazing what robust systems that you have, and I'm going to start clicking through some of these because what you're doing is quite impressive, from huge systems all the way down to very small packet systems, I guess we could call them that. But looking at what are some of the special features of your technologies, both in solar and in water, that may be different than others in the marketplace?
Well, first I'd like to say that we are a very diverse company. We're not just like your typical solar company that, you know, puts solar panels on a roof. We're very unique and diverse by, I say that we can purify water through our solar technology. So basically through reverse osmosis, we can desalinate water, brackish or seawater. And then we can also purify fresh water. So that's one angle that we can help people with water. But also, we can irrigate large farms through solar technology. And we have 5 patents, and one of the patents is Verimax. That's our technology, and it's a high-yield solar water pumping system. So we can actually irrigate farms using solar technology. And then also we can install large-scale commercial projects.
Yeah, looking at this, this is a very attractive system that you have right here in the image, where you're actually filling these tankers to go out into communities, probably it looks like maybe on the African continent. But having the solar, and with these systems where it's a package deal, you drop it in, deploy the solar panels, and then you're ready to pump, correct?
Correct. That picture is actually in Haiti during that natural disaster, and we provided 5 of our largest units called the Mobile Max Pure unit, and that unit can purify up to 30,000 gallons a day from just the sun.
Really? Tell us that again. Did you say 30,000 gallons a day?
Yep, 30,000 gallons a day, potable water for you to drink, and they're standalone. So when I say standalone, you don't plug them in, you just deploy them. They are operational in under 30 minutes, and they are self-sufficient, and they are instant infrastructure. So basically, they are your means of water, and they're truly amazing. To elaborate more on that, if you think about it from an economical standpoint, bottled water is, let's say, 50 cents to $2 around there. These products provide water at less than a fraction of a penny. So if you think of it from a logistical standpoint, the cost savings is remarkable. So basically, like take for Puerto Rico, for example, you got to get the bottled water, you fly it down there, you hope that there's gas to fuel the planes, because I heard there was problems with that. You get them down there, you got to put them on a truck. From the truck, you bring them to the place, the location. You got to use fuel for that, and this is on a daily basis. And then, also weather permitting, there might be other problems. With these units, you just deploy them, and they are self-sufficient and able to purify water right there. And the Mobile Max Pure unit, it has a battery storage device on it, so it can save energy and be used at night when the sun goes down.
And the whole thing about it too is you don't have these tens of thousands of bottles. I was in Trinidad, Tobago a couple of years ago, and supposedly they have the largest number of plastic bottles on the planet all across both Trinidad and Tobago, and they were trying to figure out a way around this. And so it sounds like what you're doing here really needs to be deployed, and this is before you have a disaster, and that's why we're doing this whole series, Alex. As you know, we discussed that, and Lynn Wells, sitting right beside me, has been very helpful in that. But looking at this, before Lynn asks his question, these can be deployed very easily then. So let's say that you have a real disaster, the roads are awash in as far as telephone poles and trees and maybe landslides and all that. So these could easily be picked up and put in place by helicopter. Someone could go down, deploy the solar panels, and they'd be ready for people to start having water within just a matter of a few hours after the disaster is over, correct?
Correct. They're operational in under 30 minutes. First, I'd like to get back to the bottled water. I'm glad you brought that up, Sam, because last year, around 50 billion bottles of plastic water bottles were consumed.
That's
so if
incredible.
you just think of that from an environmentally friendly standpoint, that's not very friendly. But,
I'm going to say that's a disaster in itself.
Yeah, but getting back to what you were saying, yes, they have been tested. They can be brought in on a Chinook using from the military. They can be airlifted. The Mobile Max Pure unit is, once folded up, it's a 7-foot cube. So they are very easily transportable.
And I think we're looking at, are we looking at that in this photograph here? We're showing the shipping of some of these units. Is that what we're looking at?
Yes.
On these large trailers?
If you look at it on that semi-truck, that is the Mobile Max Pure unit, and it becomes a cube. You bring it to the location, and then it folds out, and the solar array is opened up, and then it just lets the sun hit it, and then out comes potable water. It's a very complex technology. It has basically you put the pump into the contaminated water, and then you pump it through the complex filtration system. And if it's fresh water, it uses UV light. It goes through a series of filters, and then out comes potable, drinkable water. And then there's also the reverse osmosis technology, and that would purify seawater and brackish water.
I tell you, we're going through all this very quickly. Lynn, why don't you ask your question? I'm just going to go through these images. Lynn's going to ask you a question, Alex,
Sure.
Because it looks like we're rapidly running out of time here, and I want to show all these different deployments because it's very impressive what you have going with your technology.
So how is your company different from other solar or water purification firms?
Well, we aren't your typical solar company that just puts panels on a roof. We can purify water through solar technology, which I mentioned. We can irrigate large farms through solar technology. For example, in Egypt, we actually are turning a desert green out there by irrigating the farm, and it's becoming actually a viable food basket. It's pretty amazing.
Yeah, this is the
and then
photograph
also,
right here, Alex, for that. I think this is your Egyptian project.
correct. And then also we can install large-scale commercial projects, solar projects. So we're very unique and diverse. It's pretty cool.
Well, you've really answered the next two questions, but I'd like to go over this again. One is about the various mix as far as the products that you have, and also where you're deploying.
Right.
So we've talked about Haiti, we've talked about Egypt, so you've been in the Western Hemisphere, you're on the African continent. Where else in the world are you actually deploying, and what are some of the different uses that you have?
Well, we actually deployed 2 Mobile Max Pure units in Japan during that nuclear disaster. They actually, through reverse osmosis, they're able to eradicate the nuclear contamination in the water, so the radiation. We've also sent 12 Mobile Max Pure units to Iraq. We provided them to the U.S. Marines. We have a long-lasting relationship with the Army. We sent a Mobile Max Pure unit down to Louisiana during Katrina to provide purified water. And we also sent 2 units to Darfur to, to eradicate the cholera problem that was going on there.
Yeah, this is just amazing what you're doing. And of course, this is actually in Thailand, I believe, where you have this small package unit. And these are quite impressive in their own right. What is the production of one of these units? How much per hour per day?
I believe you're looking at the chef's unit. That is our suitcase-sized unit. It is very mobile. It can clear through customs, and that can purify around 60 gallons of water an hour.
The volumes that you're able to produce, because the average family of 6 on the African continent uses about 3.5 gallons per day, which is less than a fifth of what, or the 10th of what we use in the United States per person.
Right.
So I mean, it's just incredible the size and scale of these things. No matter how small, they're still being very robust as far as the amount of water they provide.
Yeah, and they're rugged. They're very durable. I also like to. I forgot to mention this. Actually, one of our Mobile Max Pure units just touched down in Puerto Rico yesterday, so that will be dispersed and will be put to use right away. And we also have 3 chef's units that are on their way down to Puerto Rico.
Alex, we ran out of time. It looks like that you're just going to do nothing but keep expanding and going around the world. And thank you for being with us. This is Alex Deichl. He's the Director of Marketing Operations for World Water and Solar Technologies. Dr. Linton Wells right beside me. And thank you very much for being with us as we create the Emerald Planet.
I want to...
Strawberries? Okay.
Okay, so what would you bring to my company?
What do you need?
I need problem-solving skills.
I got through high school without a car, a phone, or a computer.
No college degree, though.
Not yet, but life's taught me a lot, and I'm ready for more.
Well, you're not the typical kind of candidate that I hire. But you are exactly what I'm looking for.
Your company could be missing out on the candidates it needs most. Learn how to find a great pool of untapped talent at gradsoflife.org.
They'll test you. Try to break your will. But however loud the loudness gets, however many cheese puffs may fly, you're the driver, the one in control. Stand firm. Just wait. And move only when you hear the click that says they're buckled in for the drive. Never give up till they buckle up.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Emerald Planet, as we come to you, as we look around the globe for those 1,000 best practices, technologies, services, products, and the leaders, of course, that are making a difference as we move through the 21st century. And we'll soon have about 9 billion people on the planet, and that's going to be a 2 billion increase over the next several decades. And how are we going to be able to provide all the food, the fuel, the fiber, the water, which is key to life anywhere, and everything else that we have. And I have a gentleman who's actually for a number of years has been working in all these areas, and he's been on Emerald Planet a number of times, and we keep inviting him back. Lynn, you're just that good, so we can't do without you. This is Dr. Linton Wells II. He's Executive Advisor now for C-RASC and Cyber Center at Volgenau School of Engineering at George Mason University. And you're doing really good things out there. And thank you for being at George Mason. That's an excellent university.
Thank you very much, Sam.
Glad to have you with us. Tell us a little bit about what this Executive Advisor status really means. What is that? And why work within the School of Engineering? Because you have a little different background than that, and yet you've been touching all the fields over these many, many years.
Well, so the thing that I really enjoy are cross-cutting approaches to problems. And one of the things about the School of Engineering is let you get into lots of different types of problems, civil and mechanical and water and things like that. But also Mason is a very diverse community. So you've got the School of Business, you have the School of Law, you've got a School of Conflict Analysis and Resolution, there's Public Policy, there's College of Science. And so you can tie all of these together. Even though I'm in the engineering school, it gives me a chance to reach out across the various parts of the university.
Yeah, and this is one of those things that are happening on many campuses across the United States and around the globe, is where they're doing this integrated or collaborative status between business and engineering, or business and architecture and social sciences and all that. But I think George Mason, because of the years that I've known about the university, has really been very proactive, very aggressive in trying to do that. So how does that really fit your skill sets as far as where you were before and now you're over at George Mason? How does that really allow you to even expand and flourish even more than what you've done in the past, which has been considerable?
So by being part of the C4I Command Control Communications Computing Intelligence Center and Cyber Center at Mason, it gives me a chance to work with the information communications technology, the cybersecurity aspect of things we've done for a long time. But also the center has begun to incubate in the past 3 weeks a laboratory called Community Resilience Lab. And this ties together a whole batch of different disciplines: the energy and energy storage, shelter, heating, lighting, cooling, water and sanitation, food security, information communications technologies, and nutrition and public health, in ways that can really provide integrated approaches to these sorts of pre, trans, and post-disaster environments.
Now, looking at the image here, there's a lot of integration, but the collaboration that you have, and this is only just a small selection of all the things that you've been doing. And of course, you're the creator and father of the Star Tides program out there, but you've really been at sustainability, resiliency, and renewable energy really almost your whole professional career. And many people were not doing that. They were looking at whatever it was within their little stovepipe, but yet you've been really very broad in what you're trying to bring together in all the disciplines. Why did you want to do that and do it 20, 40 years ago?
Well, I found when I was working in the Office of Secretary of Defense that you get very channelized, even at fairly senior levels like Assistant Secretary. And you're the IT person. Why are you worried about water? Why are you worried about power? Why are you worried about shelter? You must be a power grab. So I said if I could ever get to some place where I could do cross-cutting work, I'd really like to do it. And the university is a perfect environment in which to do that. So you mentioned Star Tides, which is a global knowledge sharing network. The origin of that was a simple question: how do people die? 6 ways: too hot, too cold, hunger, thirst, illness, injury. So too hot, too cold is a problem of shelter, heating, and cooling. Hunger, thirst is a supply chain problem. Illness, injury is a problem of public safety, security, public health. So again, you have to weave these different disciplines together. And I learned a really cool term about 3 weeks ago during our Star Tides demo at George Mason, and that was transdisciplinary work. So multidisciplinary or multiple academic disciplines, got it. Transdisciplinary, you bring in the practitioners. So it's the academicians plus the NGOs, the politicians, the political people, the folks out there working in the field, and that kind of transdisciplinary approach is what you need to do.
Yeah, and you put a label on it, but before that you've been actually doing it, because Star Tides with your National Field Days that you've been doing for a number of years that I've known you, and that's how we actually got introduced, is really that whole thing where you're bringing the practitioners in, and actually in a sense they're training the academicians, the assistants, the politicians and all that. So it was really kind of interesting, the role reversal of where you had the practitioners, the inventors, and the ones that are actually doing the day-to-day work, teaching who should be the trainers or the professors. But looking at this integrated approach as far as the water and using solar energy for all that, this is really what we're all about in this program today. Tell us a little bit about that and how that solar relates to purification and all the aspects of water as it relates specifically to disasters or IDPs, internally displaced persons.
Well, I think there's several different parts to that. The first of all is water purification, by and large, depends on some kind of energy source. And you can do it with just a solar still and condensation, but it takes a long time, doesn't produce very much water. So if you're going to produce lots of hundreds of thousand gallons a day, you're going to need some sort of an energy source. Traditionally, this has been a generator, and which is fine, except you've got to bring in the fuel to run it, and you have to bring the logistics chain. So what's happened over the past several years is the efficiency of the solar panels and the ability to couple these better with the water purification has gotten much, much better. So now you can get some actually deployable units flown in a helicopter, drop them there, and in under an hour they're actually generating potentially large amounts of water. So I think that's one important part. The other part is you have to think through the intersection with the people. Technology always, sociology always trumps technology. And so how do you integrate it with the way the people work? And so one of the issues, for example, in Haiti, there was a local distribution network for water before the earthquake. People would come around in trucks with tanker trucks. People get their water for a few cents. The problem is you bring in all these bottles of water, and the international community thinks it's helping, but now it's destroyed the indigenous domestic distribution system. So when the interest wanes and the people go away, leaving lots of bottles behind them, they've also not left the indigenous distribution system to pick it back up again.
Yeah, this is one of the things that we learned, and actually a gentleman we had on some years ago was working in Haiti, and he had the only distribution system. He was serving about 400,000 people. Of course, that's a city of 2.7 million.
Sure.
But that was the most pure water they could get. But it was all based on indigenous workers. And they were using farm tanks and putting in very simple purification tablets in that, and it was costing a matter of a few pennies. And then all of a sudden you start going to these bottles, and of course then it becomes almost international market rates for that, and people just can't afford it. So looking at that, and we have this chart here, and we'll leave this up for a minute, how does that relate to this whole concept of we need to really look at what's going on through the indigenous community, and we want to enhance that, not either bypass it or destroy it?
So the point about, this is a chart of the collaborative community resilience and the infrastructures, again, the energy, the shelter, water, power, so on and so forth. And you have to start by listening. You have to start bottom up by listening to what the community needs and how, for example, we were working in one project, they said they need clean water and they needed low cost, high energy efficient shelters because they were living in trailers, but it was cheap to buy, impossible to heat, and they need broadband. Those are the three types of things that they wanted for their community. Now, someone else may have a completely different set of requirements. So you begin by listening. The next thing, though, is there's a narrative, that the people's narrative needs to be translated to what the systems thinkers, system engineers can tile these pieces back together again. And then the narrative has to come back down and say, we thought about this is what this means for you and your world, rather than trying to lay a batch of engineering on people. So the combination of technology, understanding the people, and the narrative is critical.
Yeah, looking at this, and of course what we really want to talk about then is how you have pre, and of course now you've added this term trans into this whole thing of post-disaster. A lot of this should be done in advance instead of just having all these disasters. We're constantly responding to something. It's hugely expensive. Everybody's lives are disrupted. Why can't we get to the point where we're helping people in advance of disasters when you know that probably half the population of the planet are living in high disaster or high earthquake or whatever kind of natural calamity zones anyway?
So I mentioned the Community Resilience Lab at Mason, and resilience is an important word. And lots of times people think about resilience as bouncing back. But in fact, you won't bounce back unless you're prepared. So you have to be prepared, and then I would say you should take advantage of the shocks and stresses to wind up better off than you were when you started. So my model would be prepared to bounce forward better.
And I think, and you've actually shared that with me before, and I think that's wisdom. You know, from your years of experience. So that would go to this last question we have here before we're finished, is about the mistakes. What others have you seen that we can share in about the next 60 seconds? Mistakes that we constantly make, we keep repeating it, and it's disruptive to people instead of actually curing the situation they have.
Well, so I mentioned the destroying the indigenous networks. I think that's one of the biggest things. I had a chance to talk with Ashraf Ghani, now the president of Afghanistan, former finance minister. And he was really concerned that the international aid effort in Afghanistan was paying large amounts of money for drivers and interpreters. And the problem was a large percentage of the teachers and engineers and were now working as drivers and interpreters, so the net result was you were eviscerating the national capability in the interest of trying to save it. So I think the first thing is build on what's there. Don't go in and try to just drop your own solution in there. Understand the absorptivity of the local population. How much can they really take? And then find ways to work with them rather than just imposing your own will.
Last 20-second question. What do you see for the expansion of this trans and bounce forward concept over the next 5, 10, 15 years?
Well, we've had some discussions in the last few days about what might be done in Puerto Rico to apply this. And there are also some areas in the U.S. like Appalachia where we might learn and get lessons learned for the future.
Dr. Linton Wells, Executive Advisor at the Volgenau School of Engineering, George Mason University, as we create the EmeraldPlanet.
You know what, guys? There's a lot of tree branches and dry brush over here. We should probably move the bonfire over there.
I'm guessing Smokey liked that idea.
Hey, Hard, what's this?
That's my resignation.
You're resigning.
Why? You've been putting me under a lot of pressure lately. That's why I'm ready to quit.
Oh, I forgot. I'll do better.
Please don't quit on me.
Don't let your heart quit on you. Get your uncontrolled high blood pressure to a healthy range before it's too late.
So you can't save money? That's easy as pie. Brown bag your lunch instead of going out. $6 save times 5 days a week times 10 years is $21,000. That's a lot of lettuce. Small changes today, big bucks tomorrow. Feedthepig.org.
Did you know kids who play outdoors have healthier lungs?
Totally.
I did. Did you know that boys that play with dolls make better husbands?
My son has lots of dolls. But did you know terry cloth diapers breathe better?
I did.
It's totally true.
Oh, yeah.
Did you know that strollers have the right of way on the sidewalk?
Yes.
Yep, I did. Did you guys
Did you know that kids who eat breakfast have higher GPAs?
Yeah, I know.
Yeah. That's actually what I was going to say.
Did you know babies should never touch silver? It's really bad for them.
I knew that.
Did you guys know that statistically friendly kids have more friends?
Yeah.
That's obvious.
Did you know most people think they're using the right car seat for their kid, but they're not?
parents who really know it all know for sure that their child is in the right seat at the right age and size. Visit safercar.gov/the right seat to make sure your child is protected.
I'm putting that on my blog.
I just put it in mine.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet. We look around the globe on a week-to-week basis in about 144 different nations, looking for what we call the best of the best technologies, the best services, the best products, and of course we're looking for the people who are the true leaders within a community. And many of these leaders are the ones that are working on a day-to-day basis, very practical application of various technologies. And it's amazing the amount of innovation that you're able to find in these communities if you really start looking there, instead of going in and saying, well, we have all the ideas in the United States or Japan or China or the United Kingdom and other places. The indigenous knowledge base is absolutely wide and vast. But we have a gentleman coming in from California. It's going to be talking about some new, really advanced technologies. This is James R. Lewis, Technology and Engineering Lead for Pontic Technology. He's coming in by Skype. And right beside me is our good friend and our special advisor, Dr. Linton Wells II, Executive Advisor at the C-RASC and Cyber Center at the Volgenau School of Engineering at George Mason University in Lynn. We're always glad to have you with us. And Jim, I think you're here by Skype. Are you ready, sir?
Yes, I'm here.
There you are. You're looking right over my shoulder. We're glad to have you with you. And we met several years ago, and I was intrigued by your technology. And with all these disasters going on around the globe, we're actually able to bring you on and talk about some of the things you're doing. But tell us a little bit about the vision and mission of your organization. And it's a unique name. Tell us about the origin of the name itself.
Well, thank you very much, and thank you for inviting us on your program. Pontic Technology is a startup company that's been funded by Dr. Michael Papadopoulos for the purpose of introducing a new water sterilization technology targeted specifically for third world countries, disaster relief, and IDP usage as well. The name Pontic is actually a Greek word. It's a Greek god, and Dr. Papadopoulos, of course, is from Greece originally. His family's from Greece, so that's where the name comes from.
Yeah, that's absolutely fantastic. And go back for the IDPs, that's internally displaced persons. And most people really do not know what IDPs are about. We know about refugees and escaping from war zones and all that. But actually, there's as many IDPs, internally displaced persons, from weather events, natural disasters, as well as being in war zones. Tell us a little bit about more of the IDPs, Jim, and why your technology is particularly suited to people that are displaced within their own boundaries of their country, but yet they still need to have the same services as regular refugees.
Well, absolutely. I've had the unique experience of being a Civ Mil officer, civil affairs officer in the United States Army for over 27 years. And I worked in Afghanistan at the district support team level with USAID and a bunch of other NGOs specifically for water-related issues. And I can tell you that IDPs and refugees offer the same challenges, if not more in some cases, than disaster relief efforts. Specifically in areas in conflict zones like the boundary between Afghanistan and Pakistan. There was a time when there were tens of thousands of refugees on that border that needed support. And this technology that we're offering with Pontic would be ideal for that type of situation.
Now, looking at what you're doing, why did you actually get into this whole business, I should say, because yours is a for-profit organization, but creating clean drinking water? What is it about that that intrigued you with those vast years of experience in the U.S. military, and now you're applying it and actually expanding on that base that you had in the work that you were doing with the U.S. military?
Well, that's a good question, Sam. Specifically, I did 17 missions in Central and South America, And these what we called HCA missions, humanitarian and civil assistance. We would do a Doctors Without Borders escort mission and that sort of thing. And one of the things I was charged with was ensuring that we had clean drinking water and clean water for surgical use for these missions to go into these very rural areas in Honduras, for example. And I can remember spending a lot of money and a lot of resources on these trucks filled with water for these missions. So I'm very excited about this technology because it does away with that need. We can take this machine into that area and generate that water locally without having to transport it.
Yeah, and the whole thing about this too, Jim, is that it's hugely expensive. We were talking on EmeraldPlanet just 2 weeks ago about sometimes to get a gallon of gasoline or a diesel somewhere, it's like $100. I had someone correct me and said, no, it's more like $300 if you're going into really the extreme remote areas or it's an extreme conflict area. Yeah. And to think you're spending that much much money for a gallon of water is just unbelievable. Lynn, why don't you ask the next question, please, sir?
Well, Jim, how did you come to be associated with the CEO and founder Mike Papadopoulos in building Pontic? Well,
thank you very much for that question. I am also a physicist at the Jet Propulsion Laboratory in Pasadena, California. That's my full-time job. And one of my colleagues approached me in 2015 and said, hey, there's this guy in Seal Beach that has this really cool engineering problem. Why don't you give him a call and see what it is? So I went out and I met Dr. Papadopoulos at his home, and we talked about his idea of this technology. And I was absolutely amazed because of all of my experience and the need for drinking water. And it was an engineering problem that I felt that I could actually solve. So we formed a relationship. I came back to JPL and brought in some other scientists and engineers, a thermodynamicist, some technicians, and we've been building prototypes and testing since then.
Yeah, looking at this, we have a picture of what you actually been creating here, and we have several of those, but you have what's called a disruptive technology. So one, for our viewers, what is a disruptive technology, Jim? And then how is Pontic Technologies with its patented water and fluids, and we need to explain what the fluids are all about, for sterilization and purification, is really a disruptive technology?
Sure. Well, a disruptive technology is one that's a significant departure from the standard way of doing business, and we think we have that. What's disruptive about our technology is the real-time ability to increase the level of sterilization that our water sterilization unit is able to do. For example, if we want purified water, we use a different process, real time. We can adjust the temperature than if we want sterile water, which could be used for medical or surgical uses, dental uses, that sort of thing. We have that ability to adjust that level of sterilization real time during operation. In addition to that, we have a suite of applications and computer technologies that let us remotely monitor our machines if they're in a third world country, either by satellite, FM communication, or if we're lucky enough to have internet connectivity where we are, we can monitor those machines from our research and development facility here in Arcadia, California, and keep track of the machine, make sure that it's working properly, and those kinds of things.
Yeah, and the whole thing about it, too, with all the technologies we have, you talked about the suite of technologies, which means a very broad array. Really what you're doing is you're taking this equipment, very sophisticated equipment, and making it like the center of the universe. This is the only thing that exists at that space and that location to do that particular function. And so that's really a very clever way to be able to monitor this in real time. But your thermal disinfection, why is that more effective than many of the other technologies that's readily available in the marketplace today?
That's a very good question. So we know how much energy it takes to kill bacteria and viruses. For example, at 140 degrees Celsius, we can use a dwell time of about 2 seconds and kill all bacteria and viruses in that amount of time. If we increase that temperature to, say, 200 degrees, Celsius, we can remove other toxins like prions, for example, which is the source of the mad cow disease. For technologies such as UV, although it is very good at killing bacteria, let's say that you get a virus that is masked from the UV light by a grain of sand or something, it may miss getting disinfected. And for the reverse osmosis process, it's dependent upon the membranes. We do not go through a membrane. We are a continuous flow thermal process. And in RO, if you don't change the filter, the membranes may open up, things may go through. So it's a logistically intensive process. So that's why we feel that thermal disinfection is better. We can control that temperature, and we have more certainty that we're going to kill the bad things in the water.
We have Nancy from Herndon has a question, Lynn, and why don't you go ahead and share that question for us, if you don't mind.
So the question here is the combination of solar and thermal and the other factors. Why is that so special for particularly the problems of IDPs?
Okay, that's a good question. Any type of IDP or refugee camp or disaster relief or even third world countries, there's a good probability, high probability, that you're going to be in an area of limited resources. So in our research and development facility, we have plans to design both a solar system, which will charge batteries and run our pumps and maintain our pressure using solar, and also solar concentration, which is a technology that you will concentrate the solar rays onto a heating element that will actually raise the water to the temperatures that we need for sterilization. And these technologies are absolutely vital in areas of limited resources. As was said earlier in the program, we're not going to have electricity everywhere. We're not going to have fuel everywhere. So we need to have other technologies that fulfill the mission goals.
Yeah, looking at this, and I'm going to go back through some of these slides of your technology you shared with us, Jim. This is very sophisticated, but it looks like it's all solid state. And so in looking at it that way, what types of spare parts and also technical training do you have to do on site so that this can be maintained? Or is it something because of the way you're monitoring this, if something goes wrong, you can change it from afar? Or there's something that says, danger, danger, and take care of me now, and you send somebody there to fix it?
Right. That's a good question. We design our machines so that when you turn them on and press a button, they will continuously operate for years. We have a life test that's ongoing now, and we think we could get at least a year without even having to turn the machine off and running a maintenance cycle in its current mode. Now, we'd like to monitor the machine to make sure that everything's working. We have several sensors and effectors that keep track of things, and we have a pretty sophisticated software package inside the brains of the machine that do things like fault analysis, failure analysis, and will shut down the system if there's
this
some kind of fault.
Jim R. Lewis, Technology and Engineering Lead, Pontic Technology, and thank you as we create the Emerald Planet.
So, same time next week?
Well, of course. Put away a few bucks, feel like $1 million. For free tips to help you save, go to Feed the Pig.
I dare you. I dare you to change the world. Yeah, you. Getting that college education.
I dare you to be somebody important.
Like be a teacher or a reality TV star. I dare you to stand up here. To call the shots. To be a role model.
An inspiration.
An innovator.
To be a teacher.
Think you can change my life?
Make me excited about science like you. Have a career that really means something? Then do it. I dare you.
They say you don't have to be so strong. But this is my mother, my purpose. Strength is not optional. See, I lift her now like she raised me then. So I know my strength is super, but I'm still human.
Oh, look who's here.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you on a week-to-week basis from Washington, D.C. in the United States, looking at 144 different nations, 1,000 best practices, technologies, services, and products as we go through the 21st century. And we're looking for ways that we're going to be able to take care of people as we add 2 billion new people to the planet by 2050, and possibly will be at a population base of 12 to 13 billion on the planet by the end of the century. So how are we going to actually increase the quality of life instead of just having people exist as is going on the planet at this time? And so we're talking about disasters, pre and trans, a new term that my colleague here introduced me to, and post-disaster, at the same time to really focus on water, because water is the key to life, and if we don't have water, it doesn't matter whatever resources there may be, people aren't going to exist. And we have a gentleman coming on by Skype. This is James R. Lewis, a technology and engineering lead at Pontic Technology, coming in from California. And then our good friend and colleague, Dr. Linton Wells II, Executive Advisor of the C-RASC and Cyber Center at the Volgenau School of Engineering out at George Mason University. And Lynn, we're always glad to have you. Thank you for being with us. And Jim, are you back with us?
I'm here.
Glad to have you. You have a very interesting title. When we met a couple of years ago, this technology and engineering lead at Pontic Technology. Tell us a little bit about your duties, why that's important, and why do private businesses keep adding to the research and development they're doing internally instead of going to more of the universities or the research centers? Why are they doing their own research and development?
Well, I think it's very important that we always leverage new technology. And some of these technologies tend to be very focused and pinpointed to certain things. For my own personal sake, I happen to have the experience from my experience as a Civ Mill officer in the military and my background as a physicist for NASA's Jet Propulsion Laboratory. I have the understanding and the experience to target this specific problem of water sterilization. And quite frankly, I think it's cheaper in some areas, and it's certainly a lot easier to have someone on site that can dedicate their time and effort to this specific project.
Well, the thing about what's going on with a company such as yours out in California, but also across the United States, is that really through the private businesses, you have these little mini laboratories that are going on, thousands of these, creating new technologies and ideas, trademarks, patents, copyrights, and that really adds to the robust nature of the economy. How do you see what you're doing adding to the local economy there in Seal Beach in California, but broadly across the United States, because you're not shy about your technology and sharing it with other people? You've been with Lynn through his Star Tides program at National Defense University, now at George Mason. So you're really getting the message out there. Why spend that kind of time and money to do that?
Well, it's very important that we get the message out, because at the end of the day, we want to help people. We want to introduce this technology and use it for what it's designed for, and that is to solve the world's water problems. You mentioned patents and the benefit to the local community. It's our intent to open a manufacturing facility and build these machines and deploy them worldwide, so that helps our local economy. And in terms of our patent, we were very fortunate. Our patent was issued to us in less than a year, which is unheard of for technology like this because it is so innovative. And if I could just say one word about Star Tides, it was one of the best experiences that we ever did. It was targeted. We made many great contacts. The location was great. It was just a great event for us, and I'd like to thank Lynn for the opportunity to participate.
Yeah, and every time I see Lynn, I always thank him for that, and I don't know how many times he's heard that from me. He's probably ad nauseum, but anyway, I just think what he's doing is absolutely fantastic, and of course he's a generator of ideas all across the globe, and so the work he's doing is wonderfully important. But going back to the challenges of water sterilization, pasteurization in disaster zones, why is it so difficult? And really, the extension of my question to you, Jim, is why do we keep waiting till we have a disaster before we're deploying these technologies and getting in places like Puerto Rico, the islands across the Caribbean, in Egypt and the Far East, Mexico, where they had the earthquakes? I mean, we rush these things in. It's hugely expensive. It's disruptive. Yet we could be deploying these in a time of peace and prosperity, and actually get it into the society when people really can absorb it and use it in the ways that it should be.
Well, that's a very good point. I've often asked myself that question. I had the unique experience of spending 3 months in the affected area of Homestead after Hurricane Andrew, and I asked the same types of questions. But I think a lot of it's political. It has to do with resources. At the end of the day, resources are always limited. But I think, in some cases, the best we can do is try to get these technologies into the first responder package and try to get it in as fast as we can. We don't always know where disasters are going to happen, so it's sometimes difficult to predict that. But that's a very good point. I wish I had some better answers for you.
Well, I've heard this over many, many years, and probably my dad said it, but it was not unique to him. It says that you can always make mistakes, but you have enough time and money to do it right the second time. And you know what that means is that we're spending a huge amount of money to do things after we have these major disasters. And that's really kind of my soapbox, is that we have to start deploying these technologies before the disaster, allow people to absorb it when they can get the most out of it. And when you have the disaster, then it's already there and in place. And of course, that goes back to distributive energy and water and sanitation, even food production and all these other things. Lynn, I think it's your turn for a question.
Yeah,
Please,
Jim, I
sir.
just wonder, how is Pontic Technologies' water sterilization process different than other systems that are on the market?
Well, that's a good question. We use temperature, pressure, and dwell time for our sterilization process. We control the temperature between 140 degrees Celsius and over 200 degrees Celsius, depending on the level of sterilization that we require. And we're continuous flow. Our machines are planned to operate continuously at a given flow rate, and they're not designed to stop. There's low maintenance. We don't have to change filters. We don't have to change UV bulbs and those types of things.
Well, that's just absolutely amazing. So how would you actually get these systems into places where there are disasters so that they're there in a timely manner and help people? Because, some of these disasters, people are 2 and 3 weeks later and they're drinking filthy water. They're getting, all kinds of stomach and other types of illnesses. And so it looks like we have to be much more responsive if we're going to wait till a disaster before we get it into the societies.
Right. Generally speaking, I see this as a first responder asset. Whether it's going to be on the back of a Humvee or back of an NGO pickup truck or some kind of first responder vehicle, our systems are designed to be put in the back of a pickup truck, hook up to the battery of the vehicle, and you can generate sterile water from any location. You can also take a unit out, hook up some solar panels, charge up the batteries, and leave it as a static unit. But it's a first responder package. It's designed to go in with the first wave of responders.
So looking at this, we know that across the whole world, there's probably 50% of the communities are just natural disaster zones. And so again, we're waiting to things become very dire. People are dying suffering. Why don't we pre-deploy these and have these in place, even if they're not working in the communities, but at least have them there so that when the next disaster, which we know is going to come because it's just almost as you know, as planned as the change of the seasons, that these things are going to happen. Why don't we do that? And I know we talked about resources, but it's a lot more costly to do this after you have the disaster than it is to deploy it before we have the disaster.
Well, that's true. Organizations such as the U.S. military, the World Health Organization, some NGOs, they plan for pre-deployment of these types of things. And part of it may be just educating them and getting the systems into their hands and have them pre-deployed in advance, or put them in the standard issue of disaster relief packages for, say, the U.S. military. I think that's a good place to start.
Looking at this, as far as we keep talking about disasters, but something that you and I have talked about before, these internally displaced persons, IDPs, this is something of major concern to the United Nations, and there's actually millions of them all over the planet. We have understanding, we have more people displaced around the globe, maybe 60 million people, more than at the time of World War II, which was hugely disruptive. So how do we plan more to work with the IDPs and allow them to develop in place wherever they are, instead of them having to feel they can stay there for a couple of years and they go back home? Many cases they've lost title to their land, their houses have been taken over. I mean, many different things that are happening to these people that are disastrous on one hand, but very negative in their lives. How can we have them develop in place? Or is that actually too wishful a thought?
Well, it may be too wishful a thought, but I think it all begins with education. It's very important that we have events like Star Tides and we have conferences, and we make sure that people are aware of the technologies that are available, so that the people that are on the ground, like those district support teams that I worked with in Afghanistan, or those teams that are working on the Pakistan-Afghanistan border, we need them to say, oh, hey, you know, at a conference, I heard about this thing and it would be ideal here. Let's do that. So I think education, the conference circuit, staying in touch with that, and just doing our best to get the resources in the hands of the people actually doing the job.
Well, Lynn was supposed to have a last question, but we've just absolutely run out of time, and you've given him so much recognition and accolades. And I'm just going to go ahead and ask the last question. But looking at this whole thing about the growth and expansion of Pontic technology, what do you see the growth and expansion of the organization, say, over the next 5, 10, or 15 years to introduce this disruptive technology that you have?
Well, our goal
you got to be quick.
Okay, our goal is to significantly decrease childhood and adult hospitalization due to contaminated drinking water. According to the World Health Organization, 50% of all the hospital beds in the world are occupied by patients with some kind of water contamination illness. So we want to introduce technology that takes care of that. And we want to get rid of all those plastic bottles. Everywhere I go in the world, I see mountains of plastic water bottles, and I don't want to see that anymore.
Absolutely. This is James R. Lewis, and this is our good buddy, Lynn Wells, sitting right beside me. Thank you, Lynn, for being here. And thank you, dear viewer, for being with us as we look around the globe to create the Emerald Planet.